Hey everyone, today I'm going to be doing a topic 4, a walkthrough of a topic 4 past paper question, and in specific, permutation and combinations. Permutation and combinations, I'd say they get pretty difficult, and it's not something where you can just kind of memorize how to do each type of question. You have to be kind of intuitive with it, like you have to really understand what's going on. The question I have above is a 6 marker. It's pretty hard, but I'm just going to do a walkthrough of how I would approach this. And yeah, so first let's start off with what the question is actually asking us. It says, Chloe and Selena play a game where they each have 4 cards showing A, B, C, and D. Okay, fine so far. Chloe lays her cards face up in order A, B, C, and D. Whatever. Okay, let's see. Selena's look like they're hidden, but let's see what the question says. Selena shuffles her cards and lays them face down. Okay, that's fine. So Selena's cards are face down. She then turns them over one by one to see if her card matches with Chloe's cards. So, like, it could be in any order. Let's say B, A, D, C, and clearly it doesn't match. So, yeah. She just checks whether they matches. And then Chloe wins if no matches occur. So in the example I just gave, B, A, D, C, Chloe would have won. Okay, that's fine. And otherwise Selena wins. Show that the probability that Chloe wins the game is 3 out of 8. Okay, so pretty weird question. The first thing I know is that the total possible combinations is going to be 4 factorial, right? So 1, 2, 3, 4 arranged in any way equals 4 factorial, because the number of ways to arrange anything is the factorial of that number in this case. So let's say total arrangements also my pen is pretty thick. Yeah, can't lie, don't know how to decrease that, but it's fine. Okay, so the total arrangements is 4 factorial, and I think that's pretty good to know in this case. Then it says show that the probability that Chloe wins the game is 3 out of 8. So that's wins if no matches occur. Now, if I'm being honest, that's pretty hard to show, like showing that no matches occur. So you know what I can do in this case? I can do that. I can show that the probability that Selena wins is actually 5 out of 8. So Selena winning is equal to 1 minus Chloe winning. So Selena winning, the probability of Selena winning is show that it's 5 over 8. Because then if I just do 1 minus that, because either Selena or Chloe can win, it can't be like a draw situation. So remember, Selena wins if at least one. I think at least is key here. And have they? No, they haven't bolded it, but don't know, probably should have. If at least one match. Okay, so at least is pretty key here. So what I'm gonna do is I'm gonna break it down, because it says at least one match, right? Yeah, because if no matches occur for Chloe, then it should have been at least 1 for Selena, right? Because 1, 2, 3, 4, and the opposite of that is none. Okay, so first I'm going to do is I'm going to find the probability of 1 match. So 1 match. Now 1 match with a card above. I think it's good to draw this out. So I'm just going to do 1, 2, 3, 4 A, B, C, D. This is Chloe. Okay, and then I'm going to draw Selena's face down cards like this. The best at drawing. okay? And I'm gonna be like, okay, at least one match. So it has to be at least one of the four out of these four, right? So that has to be 4 choose 1, like, because it doesn't matter in which order it's picked. Like if this is B or this is C, it has to be 4. There are only four total 1 matches. Okay, and something that's kind of weird to me right now is, let's say this was A, okay? I'm just gonna use a different color for that. Say this is A. This could be in 2 orders. So this could be, let's say this could be C, D, B, right? Because again, none of them are matching. Or if I draw another set of cards here, not the best. And remember, this is A because I'm just choosing A to be our match card. This could actually be D, B, C. Okay, so I'm like, so for every 4 total match, for every 1 match, there is 2 possible arrangements of our little cards. Okay, and 4 choose 1 in this case equals 4, right? That means for every 2 possible arrangements, that's just 4 times 2. 8. So there are 8 possible ways, because I'll give you another example. Let's say these are the face down cards, and I'll just make this one the one that matched, because remember, it has to be in this order. This could be either C or it could be D, right? So there are 2 possible pathways, if you think about it. 2 pathways to go through. Because you're kind of trying to think about it in the way that, okay, if this is supposed to be A, right? What other cards can come here? It can either be C or D, but it can't be A, so there are 2 pathways where they both work. Okay, and for each match, 2 pathways. So that's just 4 times 2. Okay, that's pretty good so far. So let's do 2 matches now. Alright, let's draw her cards again. I'm reaching the next page. Cards were A, B, C, D. Remember, I'm just gonna write C. Face down cards. Well, yeah. Okay, so now I think it's just, for example, we reached the point where we can understand, okay, now out of these 4, 2 need to match. So 2 need to match from 4. And in this case, the order in which they're chosen, for example, it's rigid, so it doesn't matter because it can't be any other order, so it has to be combination. Okay, so in this case, it's going to be 4 choose 2, because out of these 4, you need to choose 2 cards that match, either, let's say, A and B, or B and D, or A and C. Now you're going to be questioning, okay, that makes sense, but why aren't we doing the same thing where we did the times 2? And I can show you why. So let's say A and B match here. Okay, I'm just going to choose blue, A, and B. There's actually only one possible pathway, so these 2 don't match. So 1 pathway. So these 2 don't match. So different to what was here up above. You know how there were 2 pathways. It could be either C or D. Here, there's only one. There's only, in this case, there's only D and C. Okay, so that's going to be 4 choose 2. And out of the top of my head, I know that's equal to 6, but I can just show you the calculation. That's 4 factorial over 2 factorial times n minus 2 factorial. Okay, that's equal to 12 over 2 equal to 6. Okay, so now I've done 1 match, I've done 2 match. Let's just do 3 matches now. Okay, let's have our chords up here. A, B, C, D. 1, 2, 3, 4. And remember, 3 matches and 1 no match. Okay, now if I'm thinking about it, okay, that's kind of weird because you can't really have it that 3 matches and 1 don't match, because think about it. If it was A, B, C, this has to be D. Okay, let's try a different example. If it was B, A, D, this has to be C, has to be. And that contributes to our 4 matches. So it's not really 3, not really 3. So in this case, the probability of 3 matches and 1 no match is equal to 0. Okay, that's pretty straightforward. Okay, and now what we do is the probability of 4 matches and 0 no match. At this one, I think you get the point, but I'll just draw it out for the sake of it. 1, 2. Okay, now there's only really one way for it to match, because look, A, B, C, D has to match, this order. So there's only one way. Okay, so this is equal to 1. So now that I've done 4 matches, 3 matches, 2 matches, 1 match, I can add them all up. Okay, and I'll go here, I'll say at least 1 match is equal to, let's go here, so we got 4 times 2 equal to 8, okay, plus 6 plus 0 plus 1, okay, 8 plus 6 plus 0 plus 1, and this is equal to 15. Okay, perfect. So I have to show it's a probability thing. So the total possible, remember, as we go here, Selena was at least 1 over total possible. So that's equal to 15, and our total possible was 4 factorial, which is 24. Okay, perfect. 15 over 24. Okay, and if I simplify that, that's just 5 over 8. And now we have proven, if we look back to our question, show that Selena winning is 1 over 8. Therefore, ability Chloe wins. Okay, so yeah, we've proved it. Now that's a really long question, and honestly, what you could do is you could just count up all the different probabilities that Chloe wins so that there's no match. And if I'm being honest, if you're in a time crush, you should probably do that, because it's pretty hard to think about this randomly while you're under all that exam pressure. But this is how I would do it in the test, and yeah. Okay, so now I'm just going to zoom on to this question. This is a paper 2 question, so you can use your calculator in this question. I'm just going to drag it up here. Okay, so let's get started. At a gathering for 12 teachers, 7 are male. Okay, just going to write that down. 7 male and 5 female. Okay, a group of these teachers go out for a meal together, determine the possible numbers of group in each of the following situation. So 12 total for a meal. Oh, nice. Okay. Determine the possible number of groups in each of the following situations that there are more males than females. Okay. So how many go out in a group? Okay, 5. So 5 in a group. 5 in a group. I'm gonna kind of do a similar thing. I'm pretty sure it's good to visualize at this stage. So I'm just gonna draw the 5 that got for a group. Okay, so the probability that there are more males than females. Okay, so there are gonna be more males than females if it's an all-male group. I'm just gonna write all males, and that's just gonna be, how many guys are there? 7 guys. So 7 choose 5 because it's all male choosing. From 7, because remember, they're all males. Okay, perfect. So then it's gonna be 4 males, 1 girl, 1 woman. Okay, so that's gonna look like 1, 2, 3, 4, 5. The people that go out, remember, 5 in a group. Okay, and then I'm like, then I go and think about, okay, I need it to be 4 males out of a group of 7. Okay, that's fine. So that's just gonna be 7, choose 4. Because what I think about permutation or combinations is you're kind of forcing the situation, or you're choosing the situation you need to pick from. It's like picking, you're picking the possibilities from all the different types of possibilities. Okay, that's why I'm choosing like all the males, I'm choosing all the females, because I've understood that the condition needs to be, okay, more males than females. So that's gonna be all males, 4 males, 1 woman, and 3 males, 2 women. Okay, so that's 7 choose 4 from full males from 7. Okay, and let's say this is male, 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 male. This has to be female. Okay, and this female can be from any 5 females. So it's gonna be times 5, choose 1, because remember, only 1 position. And you know what I think is good to do right now? I think it's very good to go in detail of why is it times and not addition. Why are you timesing the possibilities? Because think about it. Let's say the females in this case were F1, F2, F3, F4, and F5. This 7 choose 4 will be done in whatever 7 choose 4 is, right? But this could be F1, so that's one combination. Then it could be F2, right? F3, F4. Okay, so there are 5 different times. It's like gathering all of this, and then you add F1, F2, F3, and that's the same thing as timesing it by 5. If you add it 5 times, you're gonna times it by 5. So adding would really not work, because then you would just be adding plus 5. But that's not really what you're doing. You're adding this entire F1, F2, F3, F4, 5 times. You're adding them 5 times. You're not adding 5 as a number. Okay, so that's why it's times 5. So I'm just going to write that 7 choose 4 times 5. Okay, the next one is 4 males, 2 women. Sorry, 3 males, 2 women. Now if I look at that, that's going to be M, 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 and F, F. Okay, perfect. So what I'm going to do is I'm just going to do the same thing. Remember, 7 choose 3. It's going to be 3 male out of 7. Okay, and then 5 choose 2. 2 female out of 5. okay? Because remember, I'm forcing the condition because 3 is bigger than 2. Here, what was the condition? 4 is bigger than 1. And here, all male, so 5 is bigger than 0. Okay, perfect. And then remember, it's times again, because for each different possibility, it's gonna work out the same. You're timesing by each other. So this is, again, you add them all up, okay? And you're gonna do 7 choose 5 plus, and now you might be wondering, wait, now we're adding, why are we not timesing? Because you're adding the different amount of possibilities, because it's not for one possibility, there are n number of different possibilities, there are only set amount of possibilities you can pick from, right? So 7 choose 5 plus 7 choose 4 times 5 choose 1, and then this is plus 7 choose 3 times 5 choose 2. Now, if you just put this in your calculator, I'm just gonna spend a little bit of time doing that. Yeah, so this is a calculator question, and I would say it's medium difficulty, definitely much easier than the one we just solved. Yeah, so just give me a second. You can hear the clicking of my calculator in the background. Okay, almost, and yeah. Okay, so this is just equal to 546. Okay, now moving on. I'm trying not to bash into the other working. Okay, so 2 of the teachers, Gary and Gerwin, refused to go out on a meal together. Okay, so if they refuse to go out on a meal together, let's say you have the total number of possibilities that they go out together is, let's say, any order, has to be M, female, right? So you have 12 people, and you need to choose 5. Okay, and that's fine, that's just 12 choose 5. Okay, and the reason I'm gonna do this is because if I can find the possibility that they do go out, okay, I can just subtract it by the possibility that the total possibility to find out the probability that they don't. Okay, so if I go here and I just say, okay, so total, it's kind of similar to what we did in the past question, minus possibility they do go is equal to possibility they don't, because they either do or they don't. Okay, so remember my total that we worked out here was 12 choose 5. Like, I'm just gonna explain that quickly again, because let's say you have a group of five people going out, okay, and you have 12 people, 7 men, 5 women, so 12 people, and you're choosing 5 from those 12, so it's 12 choose 5. And let's say the probability that they do go, so let's say Gary and Gerwin, I'm just going to put them separately as a block here, okay, and I now need to choose 3 people from the remaining people behind, because remember, it can be any amount of women, any amount of men at this point. Okay, so that's going to be let's say, since there are 3 spots, I'm going to choose 3. There are 10 people remaining. So 10, choose 3. Because Gary and Gerwin are already gone. So I'm just going to do total remaining equals 10 people. And I need to choose 3 from 10. Okay, perfect. So I need to find the probability that those 3 people are going from the 10, and that's just 10 choose 3. And you might be wondering, okay, why don't I times by the order or the probability that, let's say, this block is swapped around? But that doesn't really matter, because 5 people going out are the same 5 people. Doesn't matter in which order they go in this case at least. So my answer would just be the total probability. Remember, the possibility that they don't, because that's what I'm trying to find out. 12 choose 5. I've already got that from, remember, choosing 5 out of the 12 people, and now 2 of those people are gone because I've already picked them. Okay, now I just have 3 spots left and 10 people left. So 10, I need to choose 3 out of those 10, and it can be either all men, it can be all women, it can be mixed, and this accounts for everything. So it's kind of good to group them. Remember that, it's pretty good. Yeah, so now if I do that quickly in my calculator again, yeah, that's equal to 672. Okay, so that's the final answer for both of these questions. Yeah, so remember, this is non-calc. This is calc. And I'm sorry, my handwriting is not the best. Neither is my organization, but I did want to I wanted to put them side by side to kind of just show you how similar some of these questions are, and this is not me saying, okay, go out there, do every single question, memorize how to do every one of them, but just shows how understanding one intuitively can benefit you to understand another in the future. Okay, yeah, so tell me if you want any more videos like this in the future, and I'll be happy to help. Thank you so much. Subscribe.